support vector machine. It falls under the category of supervised machine learning model, renowned for their effectiveness in both classification and regression tasks. This is what was developed by Vladimir, and he refined in 1990s. SVMs excel is high dimensional spaces, particularly when there are clear margin of separation between the data classes. What the sentence means: the support vector machine gives the clear dimension about the data, how they have been classified, how the margin level has been set, how the linear line has been separated, has been drawn to separate the data points or the clusters, and how we are going to set the margin, how should be the distance between the margin and the separation line. When the distance is very less, how to select, how to make a line to separate the data points, what are the conditions we have to follow in doing the separation process. So these are the some of the points we are going to see in detail in SVM process. So what are SVMs? What are the goal of classification is? So SVM identifies the optimal boundary to separate the data points into distinct classes. Two distinct classes we are going to make to separate the data points. First one is the primary goal is to maximize the distance between the separating boundary. So second point is, first we have to select the, you have to collect the data and we have to make a cluster and you have to make a distinct class. Next thing is we have to maximize the distance between the boundaries, known as what we call as the line which separates these two data sets are called as hyperplane, and the nearest data points from the each classes. So the distance on the point, the hyperline line is this end point which is going to separate the 2 points, that hyperline, and the data which is very closer or far away from this hyperplane. That distance you have to maximize it. Second thing. Third thing is this maximizations ensures the robust classifications. As the maximization increases, you can make a very good classification. SVMs are widely employed in various applications, including pattern recognition, where we can identify recurring structures in data. We can go for finding out the what type of structure of the data we are following in the data sets. Text categorization, what's for sorting the documents by topic. Next, image processing for tasks like object recognition. This is how where widely SVMs are applied for applications. What is the core concept? The core concept is, first we talk about what is a hyperplane. We told that a hyperplane is a line which separates the data sets. So in this case, we are going to say that what is three things we are going to represent in this hyperplane. One is a decision boundary, dimensionality, optimal choice. Hyperplane is the fundamental decision boundary that separates the data points belonging to the two different classes. So two different classes, I'm going to segregate it and I'm going to draw a line. That line is called as hyperplane. That is called as decision boundary. We are going to make a particular decision. Next, what is dimensionality? For two-dimensional data, the hyperplane is a line. In 3 dimensions, it becomes a plane. In higher dimension, it is abstractly called as hyperplane. So what they say is that if it is a 2-dimensional data, if I'm going to separate it, then it is called as a line. If it is a 3-dimension, it becomes, we can call it as a plane. If it is more than 2-dimension, or we can go for higher dimension, I can call that as an hyperplane. So this is how they classify with the respect to dimensions. What is the optimal choice? While optimal choice hyperplanes might separate the data, SVM strength lies in finding the single optimal hyperplane that best generalizes to the new data. So we have to choose what type of plane or a line or a hyperplane we are going to go for segregating the data, and you have to see that the points where it is available nearer to the line or the plane or the hyperplane where we are going to do it. If the distance is very large, then we can say that it is a proper way of making clear classification between the data sets. Now, maximizing the margin. How to maximize the margin? So, in the suppose vector mission. So, first we'll see what is a margin is. It is a distance between separating the hyperplane and the closest data points from each class. So I told that the data sets, we are drawing a line or a plane or a hyperplane. That line, when I draw it, we have to find out where the data points are located. If the data points are located, which is very close to the line or a plane or hyperplane, that is called as margin. That is called as margin. What is support vector? The closest data points which lie on the margin boundary. The closest the data points which is very closer to the margin what we are going to draw are known as support vectors. So, enhanced generalization. SVM's primary object is to find the hyperplane that results in the largest possible margin, significantly improving the model's ability to generalize the unseen data and resist the overfitting. To overcome the overfitting process in my prediction. So, what we do with it is better to go for going for a support vector machine where I'm going to draw the hyperplane, then I'm going to draw another margin so that the margin may be any number of margins we can apply for our separation. When I go for the margin, we have to find out where the data are located. According to the location of the data, we have to see that what is the maximum distance is. Depending on that, when we go for maximizing the distance only, I can go for more wider class.